Okay, so in this lecture, we're going to start a new chapter and it is called Heat and Work. This is a very important chapter, obviously, and you can't really teach this chapter in theory, right? You have to solve a lot of questions to understand where exactly to apply your thinking. Also, please note that this is a thinking chapter. There are only a few questions in which you have to follow a standard procedure. However, I will try to tell you the trick to solving most types of questions, right? So, I just want you to quickly breeze through the lectures because there is not a lot of theory. I want you to move on to the tutorials as fast as you can, right? Let's begin. So, what are heat and work? Heat and work represent energy in transition. The keyword here is energy in transition. So, heat is unordered energy and work is ordered energy. You might have also heard that you can't convert all heat into work, but all work can be converted into heat. That is because heat is unordered and work is ordered. So you can go from ordered to unordered, but you cannot go from unordered to ordered. And this is, in fact, one of the laws of thermodynamics as well, right? This is called natural asymmetry. Not a law, it's just a phenomena that we have discovered. Right. An important thing to note is that heat and work are boundary phenomena. This statement is very important because you will get questions where suppose you have a container with, let's say, some water inside it and you have put a heater like this. So now you are supplying electrical energy to the heater and the heater is dissipating heat inside the water. So, what is the heat work done by the heater? The answer is zero if you take this as your boundary. Why is that? Because if you see, the heater is inside the boundary. The heater, the work done by the heater, that is the heat that it provides, does not cross the boundary. So we cannot say that the heater does some work. However, if you take this as your boundary, that is everything except the heater, then you can very confidently say that the heater will do some heat work. This is why the concept of system is also important because as you see, the work changes with what system you choose, right? So that is why you must be aware of the concept of system. So this statement I think is one of the more important ones in this chapter. Moving on, system can be said to have energy, not heat or work. Intuitively, you will always say that the system possesses some energy that is converted either into heat or in the work. You will never say that the system has heat or the system has work, right? Moving on. Now we'll look at the sign convention, quite important. Heat and work are directional quantities, as we know. Sorry, are directional. So, work and heat can either be in or out. Sign of heat is with respect to the system. That is, heat going into the system is positive, heat going out of the system is negative. In implies positive and out implies negative. And we are seeing in and out with respect to the system. Similarly, sign of work is with respect to surrounding. So, if work is being done on the system, then we say it is negative. If it is being done by the system, then we say it is positive. So, if work is going in, then we have negative. If work is going out, then we have positive. And in and out directions with respect to surrounding. So, what do you have to keep in mind? Q in equal positive, Q out equals negative, W by sys equals positive, and W on sys equals negative. Q in is positive, Q out is negative. This is with respect to system and this is with respect to surrounding. By and on, right. Okay, moving on. Heat and work are path functions. Meaning they have no meaning at a state. Again, they are not properties of a system like internal energy or whatever. They are not properties of a system. Next. So we know that for properties like pressure, temperature, volume, small change is represented by dt or dv or dp. Also known as exact differential. However, for path functions, change is given by delta q and delta w, or inexact differentials. Now, what does this mean? This means that example dp 1 to 2 equals to p2 minus p1, but integral of delta q from 1 to 2 does not equal to q2 minus q2 minus q1. It is equals to q from 1 to 2. This is a path. You cannot subtract the states. Lastly, to conclude this lecture, isolated system, neither heat transfer or work transfer occurs. With that, this is the basic introduction to heat and work. After this, I think we'll have a couple of more theory lectures, and in which we'll be solving like a couple of questions, and then we'll swiftly move on to tutes, because those are the most important part of this chapter, right?